Hey everyone, this is Miss Valentine, and you are watching the 9.1 notes presentation on studying human populations. The study of human population is also often called demography. So, when you've heard the word demographics before, usually it's referring to race or income level or gender. Demographics in general are just the study of populations, ways that you can characterize humans. So demographers look at the historical size and makeup of populations and the current size and makeup of populations to make predictions about the future, about what population growth and population quality of life is going to be in future decades. I'll leave that up there for just a moment for you to finish copying. Now, when we look at demography, we often divide it into two different groups based on the industrialization of the population that you're talking about. So we have developed and we have developing countries. And this is one of those themes that we talked about at the beginning of the year with the intro to environmental science. So, first of all, developed countries like the United States, Canada, Europe, Australia, Japan, the ones that are highlighted here on this map, tend to have higher average incomes. A lot of this came from the fact that we've extracted resources from other parts of the world and made that into wealth for ourselves. But that there are higher average incomes in the US than there is in a lot of different developing countries. There's slower population growth. So we're going to talk about some of the reasons why that is, but population does not increase as substantially once a country becomes industrialized, once it becomes developed. There are diverse industrial economies. What does that big long statement mean? It just means that there are a lot of different jobs that you can get in a developed country. There's a country or a city in Paraguay, it's not even a city, I should say more like a village in Paraguay, located next to a landfill. And all the people can do in that town is work in the landfill. So they have no other job opportunities aside from that. So that would be an opposite example to what you have in developed countries like the US. So again, we have a lot of different opportunities to work in different types of jobs because of our diverse industrial economy. And then we also have stronger social support systems, which often comes along with having a larger government or a more functional government, even. So, in terms of social supports, some of the things you might think of are welfare, food stamps, Social Security, Medicare, Medicaid, but also just you being in school right now is a social support. If you think about it, not everywhere in the world offers free education to kids. So the fact that you can read and write and learn all of these things, it's actually a social support system in the United States that we have set up. And it's just one of many of those social support systems that are meant to help people, all people. Developing countries have lower average incomes, so they might make $2 a day instead of making $8 an hour. So their economies are a lot more simplistic as well. So you're not going to have as many job opportunities. Like I mentioned, that town in Paraguay, which is in South America, it's one of these countries. I can't remember which one. It They don't have the opportunities to do a lot of different careers, a lot of different jobs. You'd have to get educated or somehow get out of that town to be able to do something more. Um, Developing countries also have much more rapid population growth. This is very common in especially India, parts of Africa, South America, where people will have a lot more children. And although the death rate is higher than in developed countries, the number of children born far outweighs the number of people that are dying. So you have this rapid population growth in developing countries. So, what is population growth like in developed countries versus developing countries? You'll refer to those notes that we just went over. Take a moment and pause the video while you answer the question. All right, so our human population has been growing a lot over the last several hundred years. It was not always this way. We started seeing exponential growth in the last 200 years or so. And a big part of that was a lot of things related to the Industrial Revolution. So, food production increased. We've had improvements in hygiene, even just realizing what germs are. We didn't even realize that washing your hands will prevent you from getting sick up until the late 1800s. So, all of these revolutions came along and allowed us to keep more people alive. So while birth rate may have fallen over the past several decades at least, the population growth has actually exploded because more people are staying alive for longer. Unfortunately, though, this exponential growth rate cannot be sustained forever. So at some point, our population growth will need to slow in order for us to survive and maintain a quality of life here on Earth. Otherwise, we'll be running into a lot of competition amongst ourselves, which, of course, we know turns into war and famine and all sorts of ugly things. So we want to figure out, like, how do we manage to sustain our population with the resources that we have and not go to war with one another. So here is the world population over time for the last 10,000 years, or 12,000 years, it looks like. It goes all the way back to 10,000 BC. So again, we had our agricultural revolution about, it looks like 11,000 years ago, when we made farming plants and animals a part of our lifestyle. Then we had our first large empires in 3000 BC. Um, so all throughout this time, slow growth was the theme. But around 1880, things just started to shoot straight up. And this is an old picture, so 2015 projected. We actually reached 7 billion by 2011. So we are well on our way to 8 billion at this point. So this exponential growth curve is that J-shaped curve that you see. One of the tools that scientists use to look at populations is called a population pyramid. And this is the population pyramid on the right. I think you're going to write about that more in the next slide. But what a population pyramid is showing is something called age structure. And it's just the way that the members of the population are arranged by their ages. So population pyramids generally have a range from 0 to 4 or 0 to 5 years. And it shows all the people that are in that age range in that population. So you can see in this population here, you have about the same number of people in most age ranges going up to about 40 years old. And then it starts to get smaller. So it's a pretty straight up and down pyramid, if you will. When you look at another country, it could have a lot more young people. So this is age 0 to 5, 5 to 10, 10 to 15, 15 to 20. So there's a lot more kids in this population than in this population. And they vastly outnumber the adults in the population. So what do those things mean? What does this age structure mean for the population? That's what we're going to look at here. So again, the age structure is graphed on a population pyramid, and it's essentially just a double-sided bar graph. So you have males on one side, females on the other side, and it just shows the percentage of the population that is male or female. You can even look at the specifics of this one is for France. So in France, you actually have more females than you do males, and most likely this decrease amount of males compared to females in this age range was most likely World War II when this picture was taken. So if you had a lot of males going to war, oftentimes you'll see there are fewer males than females in a particular age range. If you have slow or no growth rate, that's what you're going to see in this type of population pyramid. It's going to be a very even distribution of ages, almost like a straight line up. Of course, it's curving a little bit because there are people dying, but it's very, very slow growth rate. You don't have a lot of change. If you have high growth rates, you have a lot more younger people than you do older people. So they're having a lot of children, and there's more of a steep incline up the population pyramid. Okay, so let's review what we just learned about population pyramids. First of all, you're going to write out what does a population pyramid show. So that is the first part of this pit stop. Then you're going to draw a sketch of population pyramids with low growth and one with high growth. And I gave you a structure for that right here. You're going to do some upside down T's, label one low growth, label one high growth. And then what I want you to do is just draw lines across the upside down T to represent what the population pyramid would look like for a low growth population and for a high growth population. Pause the video while you work on your sentence and your sketches. Survivorship is another thing that demographers look at, and it's really just the percentage of newborn individuals that are expected to survive to a given age. And when we're studying human populations, it's usually expected to survive to reproductive age. To predict survivorship, demographers look at all the people born at the same time and then notes when each member of the group dies. So oftentimes when we're looking at survivorship, we're looking into the past and observing certain patterns of survivorship in certain time periods. For example, if we were to look at survivorship during the 1918 flu pandemic and World War I, you'd see survivorship is much lower, both for males and for females, because of the war and because of the flu pandemic. So you can compare populations from the past to populations currently. Fertility rate is one of the most important things that demographers study because it's basically the number of children that a woman will have in her lifetime. And I think I may have mentioned this when we talked about populations in general last week. The record for a woman having babies was like 69 children in a combination of quadruplets and triplets and twins, which I can't even imagine having 69 children. And in the 1700s, no less. That's crazy. But really, the fertility rate is generally a number out of 1,000, how many they're going to have. The replacement level is the average number of children each set of parents must have in order to replace themselves. And you might think to yourself, well, duh, that's going to be two. You need to replace a mother and a father, you need two children. But oftentimes it's slightly more than two in a country when you're doing the average overall, because some of the children will not survive long enough to reach reproductive age. Now, fertility rates in developing countries tend to be very high. That's why they have high population growth. But in the United States, we've seen fertility rates actually drop over the past century. So we actually started off with high fertility rates at the beginning of the 20th century. In 1972, after the baby boom was over, we dropped below replacement level for the first time in our history as a country. Fertility rates remain pretty low, but we have gone back up closer to replacement level in recent decades. So if you take a look right here, replacement level in the US is approximately 2.1, which again is because women have to have some women have to have more than two children because some of their children will die before reproductive age. So 2.1 is actually a pretty low replacement level. But looking at the replacement level here, you can see during World War II, the rate of births was low. We had the baby boom after World War II, and then the baby bust was in the 1970s. So we dropped below replacement level, but we have gone back up above replacement level since then. So for your next pit stop here, what is the replacement level and why is it more than two in most countries? Again, please pause the video while you answer this question. Migration is another thing that demographers study specifically because of how it affects the overall population. So birth is one way to get individuals into a population, migration is another. And just migration in general is the movement of individuals into or out of a population. So just moving, not being born or dying, moving in and out of a population. Movement into an area is called immigration, which is one that we hear a lot about in the United States because a lot of people do want to immigrate here. And then movement out of the area is called emigration. with an E. I think of the word exit starts with E, immigration starts with E, it's exiting the population. And when it comes to immigration in the United States, if we did not have immigration, we would actually have a very slow growth rate, and it wouldn't be sustainable for our economy. So immigration is important, particularly in countries where the birth rate, where the fertility rate is very low. So the populations in many developed countries might be decreasing if not for immigration. So we have also seen a dramatic decrease in death rates over the past 200 years. A lot of this has to do because of developments that came along with the scientific and industrial revolutions in the past couple years. We've been able to feed people. So the more kids you can feed, the more kids you can have. So adequate food, having clean water and sanitation, that has been very important in keeping people alive longer. Safe sewage disposal. People used to just walk out into the street and go to the bathroom in the middle of the street. Now we have a place for that to go to get treated, and eventually it's put back out into the environment once it's deemed safe. And then we also have vaccines now, which prevent millions and millions of people from dying. So while there is some bad information out there about vaccines being dangerous, it is responsible for saving millions and millions of lives over many hundred years, or a couple hundred years since we've used the practice. Another one would be antibiotics as well. So these medical developments that have allowed us to keep people alive for longer are causing our population to grow more rapidly. Life expectancy is the average length of time an individual is expected to live, and it's most affected by infant mortality in a population. So infants less than 1 year old, if there's a large death rate for them, which is it's the most fragile part of your life when you're in the age of 0 to 1 years old. If there's high infant mortality in that age range, it's definitely going to affect the life expectancy of that population. And this is often something that we look at when we're studying populations and the quality of life amongst populations to see if there's a high life expectancy. Usually you have a higher quality of life. If there's a low life expectancy, generally there's more struggle, a lower quality of life in those populations. Life expectancy has been increasing slowly but surely. You can see this is the world population here. Developed countries definitely have higher life expectancy, while least developed countries have a much lower life expectancy. So certain diseases and conditions can come about to lower life expectancy in some areas. So AIDS, tuberculosis, some of those things can reduce the population size in dense areas. Remember, density-dependent limiting factors. But as we have more medical advances, we are able to raise our life expectancy. All right, so here we are at our next pit stop. What are 2 factors that have allowed death rates to decline over the past 200 years? Pause the video while you answer this question. All right, and on to our demographic transition. That sounds like a big fancy word, but really, demographic transition just basically means population changing. So it's demography is study of populations. Transition, if you think of a transition, it's when things are changing. So it's the change of a population. And all it is showing a general pattern of change from high birth rate and death rates to low birth rate and death rates. And it goes in 4 different stages. So this is basically what happens to populations all over the world when they go from being pre-industrial or before they become developed, all the way to post-industrial, which is after the Industrial Revolution for that country. So this is something that they've actually come up with in the last several decades. And they realize that the demographic transition, the changes in the population, is directly related to economic and social progress within the countries that these populations are in. So let's talk a little bit more about some of these phases in the demographic transition or the population change. So the first stage is a society that is pre-industrial. So this would be what humans have been for thousands and thousands and thousands and hundreds and thousands of years before the agricultural revolution. So it's a pre-industrial age. The birth rate is high, the death rate is high, and so the population remains stable. It might continue to grow as long as there's no plagues or huge causes of death. But generally, when you have the first stage, population is just growing very, very slowly because both high death rates and birth rates are high. In the second stage, a population explosion occurs. And this is when you have death rates drop. So the birth rate stays high, death rate drops, and drops as a result of hygiene, nutrition, and education improvements. The medical advances, all of those things we talked about that have allowed the population to grow, those are what happen in the second stage when you have access to those advances. In the third stage, the population growth slows because the birth rate decreases. So the birth rate comes close to the death rate, and then the population stabilizes or becomes a very slow growing population. In the third stage, it is actually better to have fewer children. So it's advantageous to have smaller families because in an industrialized society, which is what you have in the third stage, it's very expensive to raise children. So it's actually beneficial to have fewer children. Small family sizes are better. In the fourth stage, which is what we are currently in the United States, the birth rate can drop below replacement level, so the size of the population begins to decrease. And I would say we've brought it back up closer to replacement level now, but this is ultimately the post-industrial stage. So after the industrial revolution has taken place, you have to count on some immigration as well to help stabilize your population and make sure that you have enough individuals in the working part of society in order to support the older individuals. Now, one of the biggest things that contributes to population growth is the status of women. So increasing education and economic independence for women is the key thing for reducing population growth. So in the demographic transition model, the lower death rate of the second stage usually happens because of an increased level of education. So people are more aware of hygiene and nutrition and how to take care of themselves better. Educated women also find that they don't have to have as many children to ensure that some of them will survive. So they have at their disposal family planning techniques. They also have economic independence if if the cultural norms of the country allow it. So basically, if you're a woman and you don't have any other option when you grow up except to become a mother, you're going to have a lot of children. But if you have an opportunity for an education and possibly a job outside of the home, you're more likely to wait to have children, wait longer to have children, and then have fewer children as well. So the economic and social status of women is key in reducing population growth. Now, next week, you are going to watch The Eyes of Nye on population, which is going to talk a lot more about this issue, in particular, how governments are trying to reduce their population growth by increasing the status and education of women. Whew, check out those damn fish. They just can't get enough food, can they? All right, guys, so we are writing a 5-sentence summary. Read through your notes again and try to write some of the key points of this section.